Hello and welcome back to my crazy electronics projects videos for my MegaWang 2000 Turbo Edition hardware. We're going to be looking at the Commodore 64 2MB RAM expansion with DMA transfers today. And thank you very much to PCBWay for delivering a lovely working board that worked first time. And now what we're going to do is that we're going to start looking at the code for testing the DMA transfer. So this code here was some code that I added to the unit tests. So as usual, I'm going to be running this in emulation and then running it on the real hardware. So basically the idea behind this DMA functionality is that the Commodore 64 can use the expansion RAM to store information or data onto the expansion RAM, and then at a certain point can tell the expansion hardware to DMA, so direct memory access, this data from the external RAM hardware to the MegaWang hardware. And this will free up the Commodore 64's CPU and will hopefully allow a lot faster, more reliable transfers. So in the emulation framework, I added this extra piece of syntax here which specified the new 32-bit interface running at a particular clock speed, and that's because the speed of the DMA transfer can be adjusted by plugging in a completely different CAN oscillator. So that was a very quick execution of the emulation. In fact, it goes by so quickly, and that's because it's a unit test. We're actually not really meant to be able to visually validate this in real time because it goes by so quickly. But what this emulation framework does is that it saves out each frame anyway, so that we can then analyze this for expected behavior. So this is the frame just before the DMA transfer kicks in, and then here is the frame when the DMA transfer has actually started and completed. These diagonal lines are basically bus contention lines. Because I'm sending the character data to the character screen during the visible portion of the display, then we get contention. The next frame after shows the updated character screen layout for the first few rows there. And that's hopefully what that board is going to be showing us as well when this is actually executed on the real hardware. So the same code that we just saw is going to run on the real hardware. So this is the default pseudo semi-random state, and this is good. It's good to see. It means that the video hardware is at least kind of working. So I'm going to use the command line this time for easy transfer to the Commodore 64. And the screen goes off and the screen comes back on again, and there's the kind of like the power on test video pattern. There's the output from the Commodore 64. It's waiting for me to press fire, so I'm going to press fire. Watch the middle of the screen. The bus contention should flick up for a few frames there. Now I've made it loop around so I can hold down fire and it will retry and re-execute the DMA transfer every frame, so that's a lot easier to see for the bus contention. This is where it differs obviously from the unit test, and we can see that the screen data has also updated to include the expected character patterns from the expansion RAM. So this is a successful test of a Commodore 64 sending data to its expansion RAM and then telling the expansion RAM interface to DMA that data to the MegaWang video hardware. So let's look at the emulated screenshot. So this is the screenshot from the emulated test run when it was running the unit test, and then this is the hardware screen. So we can look at these two displays side by side, the emulated one here on the left and the hardware output on the right, and we can see that they are identical as you would expect because it's running the same code, so we would expect to get visually the same result. So we have a character screen there, we have a vertical column of sprites, we have some expanded sprites, we also have the tiles screen. This is kind of like a video test card pattern, if you like. It tests at least at a high level that the video hardware is working correctly. So I'm really pleased with that test. There was only one small little bug, and we'll get onto that in more detail right now. This was a bug in my hardware design, by the way. It's not a bug in PCBWay's delivery of the PCB. Their PCB is working exactly how I designed it to. It's just that I had a slight problem. So I noticed that I had to comment out the reading of latch 13, which basically tells the Commodore 64 the status of the DMA transfer. And when I went back and actually checked the schematic, this area of the schematic that I'm highlighting here, oops, I've highlighted one extra signal that I didn't need. This area of the excuse me, schematic outputs register 13, and it outputs one bit for register or latch 13, which basically gives the status of enable fast DMA. Unfortunately, this bus driver here doesn't get correctly switched off when the bus transceiver rather doesn't get correctly switched off when I'm accessing latch 13, and that meant that the Commodore 64 is seeing conflicting signals, so it was never reading that the fast DMA flag was being cleared, unfortunately. So this issue didn't crop up in my simulation unit testing because the test wasn't actually looking for the right value. I wasn't actually testing for this, so it wasn't reporting a data contention or anything like that, which is unfortunate, but it's only a small little piece of functionality there. I'm going to be producing an extra version of this board just to really, and removing probably the debug headers and stuff like that, because I don't need them anymore and it makes the board more expensive. So I can now go into cost reducing this board now and producing a couple of different variants perhaps, and also allowing different RAM expansion modules to be plugged in as well. Maybe I'll do that. But anyway, this board works, pretty much perfectly. And according to the design, it works exactly how the design is specified. So I'm really happy with this. I'm really happy with PCBWay again for producing, another really well put together board from my designs. I'm always amazed that when I get back a design, it actually works as intended, and PCBWay do a really speedy, good job of providing this to me, especially to hobby developers like me. It really is a valuable service that it allows more of us to experiment with electronics. So thank you very much, PCBWay. So if you like these kind of crazy electronics videos, then please do consider liking or subscribing to this channel, and I hope to catch you around next time. Take care, have a great day, evening or night, wherever you are.